Welcome to this video tutorial. In this video tutorials we will touch some of the things that we have learned during the different units of statistics too. So I recommend you to pause the video and read carefully the statement, and then after that I will develop the solution. In this case, we are interested in knowing if there are differences in the mean time that students spend in the enrolling process in two universities. So in that case, we have from the first university, we have a sample of 100 students, and the mean time is equal to 135 minutes with a standard deviation of 15. We know that this population follows a normal distribution with expected value m sub 1 and standard deviation sigma sub 1. In the case of the second university, we have also 100 students. The mean time in enrolling is 122 with a standard deviation of 10. In that case, both variants of both populations are unknown, but we can consider that they are equal. As you know, the difference between means is going to be distributed also as a normal, with the expected value, the differences between the expected values, and the standard deviation, the square root of the sum of the variances. As we have samples that they are enough big, there are clearly greater than 30, both of them, we can approximate the variance of both populations by the point estimators of the sample variances. Now, or you have to notice that if this is not the case, the samples are not enough big, we couldn't do this approximation, and in this case you know that we have to use the weighted variance. But in that case, as the samples are enough big, we can approximate each of the variances of both populations by their sample variances. If we apply that to our numbers, we have that the difference between sample means are going to follow a normal distribution with the difference between expected values that we don't know, and we want to estimate a confidence interval for this value, and with the standard deviation that is going to be the square root of 15 to the square divided by 100 plus 122, by 10 to the square divided by 100. Remember that as we have used some estimators in order to fix the population parameters that we don't know, the standardization of the distribution is not going to follow a normal distribution. In that case, we'll follow a t-student with n sub 1 plus n sub 2 minus 2 degrees of freedom. So in our case, this standardization will be the difference between our sample means, that is going to be equal to 13, the difference between the population means that we don't know, and the standard deviation will be equal to 1.8. And this will be in a t-student of 198 degrees of freedom. So if we develop our confidence interval, will be centered in the difference between means, 13, less the point in a t-student of 198 degrees of freedom that led to the left side, a probability value of 0.005. this point is minus 2.6 multiplied by the standard deviation of the distribution, 1.8, and the upper bound of the interval will be the difference between means, 13, multiplied by 2.6, that is the upper point in a t-student of 198 degrees of freedom that led to the right side a probability of 0.05 multiplied by the standard deviation that is equal to 1.8. So if we have 0.05 to one side, 0.05 to the other side, we have in the middle 0.99. So the final interval will be 8.32 and 17.68 with a probability of 0.99.